Hello, everybody. Thank you for attending the session. My name is Zach Probst. I'm happy to be here today, back for another Nodes session. Today we're going to be talking about building graph-powered applications with Nodestream. In particular, I want to dive into how you might take a real-world application, architect a solution around Graph and Nodestream, and go from there. Um, oops. Like I said, I'm happy to be back at Nodes. This is my fourth go around the run of Nodes. It's always a fun conference. I speak at a fair number of conferences, and I always enjoy the ones that are graph focused and developer focused because you all share the same passions I do. So it's fun times to be back for another round of Nodes. Just to outline a little bit of what I'm going to talk about today. I'm going to gush over graphs with you all very briefly for just a moment. Overview Nodestream, if you're not familiar with it, what it is, what's new, and what's coming down the pipeline. And as well, then I want to dive into the meats of this, which is going to be all about building sort of an example application with Nodestream. I've done a fair bit of this before, but I want to do this in a more real world context this time and dive into some sort of architecture and design around it and put it into a real domain. So that's what we're going to focus on today. I'm going to start with a quote by my colleague Chad Close. He says, "We can now map possible exposures in seconds, something that previously took engineers hours or days to manually figure out." And it's a bit of a quote from a case study that we did with Neo4j a few years ago now about some of the problems that we were able to solve with Graph. And I put it up there because it's emblematic of the beauty of certain problems that you can have with, you can kind of suss out with Graph. I think there's a brand of problems that just kind of unravel if you solve them with the graph or you start to model them with the graph. And in particular, I kind of think of it in sort of two buckets. There's the kinds of problems that are, I call highly exploratory. And what I mean by that is like, you're not quite sure what it is that you're solving for yet. You don't necessarily know how all the elements in your domain interact. You're not quite sure of like what the most optimal solution for things is. In graphs, particularly Neo4j, being schemaless, allow you to kind of just change and adapt and explore your universe of data, right? And kind of touch and feel it to a certain extent. And then also it lets you kind of model that data in sort of a real world way, a sort of a tangible way. Model data in terms of nouns and verbs and not tables or documents and things like that. It's very clear, you can build a graph that kind of fits your understanding of the world and then change it as you learn about your domain. And the second type is what I consider highly analytical, which is often kind of on the way on the other end of the spectrum, where you have a really well-defined model. You have a very clear relationship between data and data types and entities in that domain, and you're trying to extract these really nuanced insights, right? Ones that rely on um, deep understanding or deep queries into friend to friend, friend to friends relationships. Stuff where if you're tempted to do these deep nested queries or sort of data science algorithms, that's kind of what I would consider a highly analytical one. And so these two spaces is kind of the emphasis behind Nodestream and why we built it. But first, let me talk to you just very briefly about what it is. Um, uh, Nodestream is all about working with graphs declaratively. And first and foremost, the top level feature of it is that you can map your structured data to a graph structure completely with YAML, with configuration. You don't need to write code. You don't need to build your own ETL pipeline or rely on some tool. It's a simple framework. Take this data, move it over into a graph from all different data sources, Kafka, files, Athena, S3, whatever. Um, all different data sources and warehouses and information can be plugged into Nodestream, send that data into your graph. It's the glue layer between the things. Additionally, it's also really meant to sort of help you evolve your application over time. Like I said, especially in those highly exploratory cases, you're starting with some understanding of your data, understanding of your graph, but you're going to want to change it. You want to modify it and improve it over time. And Nodestream has a feature called migrations, very similar to like database migrations if you've used like Flyway or Rails or Django migrations. Very similar process where it sees how your application changes and then updates your graph accordingly. Um, a lot of tools in this space also tend to not be what I would consider developer friendly. They don't work as command line tools or things of that nature. They work as um, products or utilities or sort of more data oriented tasks. And I'm a developer. I want a tool that fits into my development workflow, that's tracked with version control and packaged like any other application. And Nodestream fits that bill perfectly. It's also what I call stack independent. So you can run it in any environment. It doesn't have a lot of dependencies, and it's meant to fit into your existing architecture. And I'm going to talk a little bit more about that in a minute. For those of you that might have seen my previous talks in Nodes or have uh, played around with Nodestream yourself, that may not be too much of a newsflash for you, but the way I like to posit it is that this is Nodestream's upshot, right? I don't have data to back up these numbers, but this is the goal, at least, of the framework. You can start with nothing and get to a graph in like 5 minutes, and that you don't spend any time writing ingestion code, queries, that kind of stuff. You simply get your data, you describe how you want that data to be transformed into a graph, and Nodestream makes it happen for you. Again, for those of you that are kind of familiar with the framework, you might be curious what's new since last year. And there's a bunch of different changes. I pulled out a few that are in the highlights. First and foremost, I wanted to call out schema enforcement. Think of it as your pipeline's very own TSA, making sure that what goes into the pipeline is only the stuff you want there, that it fits the data, that model that you're expecting, and it can do it automatically as well. It can infer that schema and then enforce it during the execution of the pipeline. Another feature is checkpointing. What I mean by that is imagine a disaster situation occurs. The graph goes down, or the cloud environment you're running in kills your process. Nodestream can automatically recover from these now. And so you can build applications that have a pretty strong durability requirement now that features like checkpointing are in. And then finally is conditional execution. This is sort of an odd case in the declarative framework where you have to have everything mapped the same way. But with conditional execution, you don't anymore. You can simply specify, hey, this relationship only exists when this property is set to true. And so now you can start to evolve graphs that are even a little bit more sophisticated and nuanced than you could before. All right. Here's my take on a road to 1.0, because I see that as what next. Right now, Nodestream has a great stable foundation, and I'm going to talk to you a little bit more about that in just a moment, and show it to you in real life. And it's become widely used by companies, by teams inside and outside of Intuit, where I'm from, and it has garnered a fair amount of stars and traction on GitHub. And so there's a nice little community forming around it. And so I think that's a good time to try to draw 1.0. And hopefully over the next little while, we're going to work on some of the ergonomics, some of the error messages, cleaning up some of the rough spots, polish down and sand off some rough edges here and there. And then the last thing I think is worth mentioning is that right now, Nodestream has a fair amount of things it pulls along with it, and we want to trim that down to a mere few and kind of modularize the framework into an ecosystem of dependencies as well as the core framework itself. All right. Now let's get into some fun stuff. Let's build an application. I'm going to start with talking about kind of the domain that I chose with, and a little bit of an anecdote here. A little while back, when I was trying to develop this talk, I was sitting in a planning meeting, and we were trying to figure out like what's the order of operations. How do we take this thing we want to make and get it to MVP as soon as possible? Like, what's the critical path of tasks that we need to execute? And like, so we were like thanklessly combing through Jira, trying to figure it out, trying to narrow it down to the most minimal set of things that we could pick up and work on, and we would trying to negotiate all the dependencies of a project. For those of you that are developers, I'm sure that's a familiar feeling. And so I kind of want to take like a to-do app, but glorify it just a little bit to demonstrate where Nodestream and Graph can fit into an architecture like this. So imagine we've got a three-tiered app. It's all about tracking tasks and dependencies. That's pretty easy to build, a little application in, a little while, especially now today with Gen AI that, tracks exactly that information. And let's say, for the sake of argument, it stores that into a SQL database. You may be wondering, like, Zach, what are you talking about? This is a graph conference. We're talking about SQL, like that's the enemy. What are you doing? I think we have to realize that a lot of applications are already built like on SQL databases or document databases. And Graph, while they are awesome, don't have the like 50 years of optimization that relational databases do, right? And so it's a very tempting data store for a lot of applications. But we're here talking about Graph, so there's got to be the kinds of problems that are best suited with Graph to solve. And so there's a couple here that I highlighted. This first is like this idea of like a bottlenecking issue. So imagine you have a lot of things that depend on one issue to be done in order to unlock, the whole ecosystem of next tree of tasks that are out there to do. If we can just clear this logjam, we'll open up so many opportunities. That's kind of my idea of a bottleneck. Um, and then the second one is kind of this execution order. This goes back to what I was saying a minute ago about trying to figure out, hey, how do we get to this point? What do we have to do? And it turns out, I think both of these are really nice demonstrative kind of queries to run that are much better suited in a graph than trying to hammer out some SQL to figure it out. And so that's what we're going to talk about. I'm going to show you that application. But before we dive into the code, excuse me, the code of it, here's kind of the architecture we're working on. We have a developer, they're creating tasks, they're creating dependencies between those tasks, and I didn't feel like building a little UI, so I just created an API. And so imagine we're defining all of that, and right now it's just getting put into our SQL database. Imagine this as a stand-in, like I said, for Jira or something like that. And then somebody else acting as like a manager or a scrum master or something is trying to figure out that optimal execution of tickets. What are the things that we need to pull in, work on next, staff, make sure we get done to keep the project moving? And that's kind of where their focus is. They don't necessarily care about that creation flow. They're just trying to reason about the things that they've done. And so the bolt-on here is this kind of graph architecture. And so what we're going to do is we're going to create a Kafka topic, and then we're going to use Nodestream to ingest sort of a replica of our database into a Neo4j graph. And then we'll use that graph as the analytics engine behind trying to answer those questions of how do we optimize task execution and so forth. All right. So with all that out of the way, let's dive into some code and see how this works in reality. So what I've done, I'm going to show you a little demo first. What I've done is I've started up a bunch of containers in the background. And those containers, I'll go ahead and show you the compose file. I've got a Postgres database as the stand-in for our sort of persistence store that we have today. I have a Kafka queue. That's going to be our sort of event bus into the graph database. We've got Neo4j itself, and then a container for both the API and our Nodestream ingestion. And to show you this Nodestream file, it's pretty straightforward in what it might be doing. We're going to go ahead and pull in Nodestream's built-in Kafka connector. And we're going to connect to that Kafka server that we have in our environment. And then when each event comes in, which is going to represent a task, we're going to map that to sort of the project that that task belongs to, and then what tasks it depends on. And so with just this little bit of YAML, we're going to be able to build a graph of our entire application, which is pretty cool. So with that, I'm going to go ahead and run a quick little demo script to walk through this application sort of front to back. So like I said, it starts with sort of this data creation. Imagine developers creating tasks and creating dependencies between those tasks. That's what this first step is going to do. So we're creating sort of this website redesign project. We're going to create a whole bunch of stories and tasks that need to be executed. Don't worry about the extra metadata here, but imagine that we're putting all of this data in. And I can show you what that looks like sort of as some, just raw JSON, not particularly insightful. But what we start to glean out of here is, again, we're seeing a bit of this dependency stuff form, that certain tasks depend on other tasks. And while this is flat and we have all the data here, it's hard to kind of get a grips on it because it is, just kind of this flat structure of data. In the meantime, while I've been talking about this, what's been going on is I've gone ahead and that Nodestream process in the background has synced our data that we just created into the graph database. In this format, you can already start to glean a few insights out of it. You can see that there's certain tasks here that seem to have a lot of dependent tasks on, but it's a little bit of a mess. You can start to tease it apart, but while this is fun to explore, this is definitely not the interface you might want to present to the Scrum Master or the Dev Manager who's trying to make sense of this and just trying to get some work done, right? They're more interested in the next phase, which is sort of this graph analysis phase. And so I'm going to go ahead and run a few queries here. And what it's doing here is it's just running some particular API endpoints that actually are executing graph queries. And we'll show you those graph queries in a second. But now we can get some of those insights to those questions that I brought out in the beginning. And so for example here, if we want to try to get this task done, which is task 13, which is deploying to production, what's the critical path, right? Well, to deploy to production, we need to deploy to staging, we need to do some performance and integration testing, we need to implement some page, we need to do a security audit, and we design it. And this is kind of the whole path, right? So if my goal is to deploy sort of an MVP to production, this is all I need to do, right? This kind of query is deeply nested, right? There's a path that we took to get here, and that's really a nice kind of query to run in a graph, and we can do some deeper analysis on top of that as well. One example is sort of this impact, right? So imagine, a story is getting delayed. In this case, I picked the security audit because I work in security, and I thought that was kind of fun to make fun of security. But imagine the security audit's taking forever, and that's held up. It says here it's held up 11 tasks. It's shown a few here that it's directly impacting, but because those things are dependencies for other tasks, that amount is actually much bigger. And so that's kind of that friend of friend kind of queries that are more and more deeper out as we go along. And this, again, another great example of the kind of insight you can glean from a graph query that would be really quite hard to do as a SQL query. And that's the little demo. I'll spend a few minutes just to try to untangle some of the specifics of this code. We'll dive into it a little bit, just kind of show you through, and then I can take a couple questions probably at the end. So let me hop into the code. Showed you that pipeline. but what's making this happen, right, is essentially just this app code. And if you're familiar with Python, it's going to be a very simple demonstration. There's not a ton of code here. Essentially, we have a database where I'm just using SQL Alchemy here as an ORM to the database, but this is defining our SQL relational model to this data. And so, there's, the estimate, there's what project the task belongs to, all that kind of stuff. Exactly the same kind of stuff we modeled with the graph, but imagine this kind of as your legacy SQL application. And so we don't really want to touch that, right? We keep that kind of the same. I want to add this insights layer on, and I want to do it with graph. And so what's happening under the hood is, like I said, we're producing sort of events using Kafka onto a stream that Nodestream is consuming from. And so here is exactly that code of just producing content onto the Kafka topic. And what's happening under the hood is in the API here, when we're pushing stuff, we're ultimately creating tasks and then sending events to Kafka. So we've basically kept, we had a legacy application and we were doing everything we normally did, we're kind of just tacking on here this, hey, send a Kafka event kind of component to it, and then we're building a graph completely separate from our current application. But it can't be completely separate, right? Because we're trying to surface these results. And so there's a number of graph queries in here as well, in order to do these impact analysis and bottlenecks. So those queries are here. And so you can see that these are actually pretty simple queries. If you try to do the same thing with SQL injection, it would be monstrous, or SQL injection, good Lord. With SQL queries, it would be monstrous, right? You have to do very complicated SQL queries here. And for a lot of these, we're doing very simple, Cypher queries that you'll learn on day one of learning Cypher. And so hopefully this kind of demonstrates some of the power in terms of kind of integrating graph as sort of a secondary data store. And I think this is a great way to start to prove the value of graph applications. Many graphs are sort of fit into this sort of analytical workload where you are trying to extract insights that you can't do with the data you have and the way it's structured now. Let me see here. I think that covers the majority of the code. I want to zero in on a couple of the minor details with the Nodestream configuration. This app, all of the Python, none of that was Nodestream. That was just this API to try to build it into an existing application for the purposes of this demonstration. This file, just pure configuration, is a sort of Nodestream component, as well as this nodestream.yaml file, which is sort of your project. Again, YAML. So for this application, it took exactly 0 lines of like actual code to implement this whole feature. Inside of the Docker file that's running that Nodestream command, there's nothing hidden away in there. All we're doing is just installing some dependencies and then just running a Nodestream command. And then from there, you have a graph. You can do the insights, you can do analytics, you can do whatever you would like to do to build that into your application. But at the end of the day, it's completely separate from whatever you've built in the initial version of your application. You're just getting all those graph insights sort of on the side using Nodestream. Also like to mention here that if you wanted to use something else, you wanted to use SQS, it's as simple as changing around this block of the code to consume from wherever it is you want to do, right? Maybe you have files that you're storing in S3 example, or whatever other examples I mentioned earlier, they all apply. And you can even build custom components as well if you want to like scrape data from your API as opposed to sending events to a completely separate system. And all of this is completely, decoupled from Neo4j and the Cypher language itself. So you don't have to learn all of those details right away in order to build your graph, right? You look through this code, and none of it is Cypher or Neo4j specific. We're just describing the graph that we want, and Nodestream is going to do the translation to build that into a Neo4j graph for you. With that being said, that was all the content I had planned, and I'm happy to take any questions if there are any.